welcome. This is How Did the Elk Cross the Road? My name is Eric Proctor. I work for the Arizona Game and Fish Department. If you are not familiar with the Arizona Game and Fish Department, we are the state wildlife agency, the state agency, government agency, that is responsible for managing all of Arizona's wildlife species, which is well over 800 species of native wildlife that we are responsible for making sure that they're doing okay. So we make sure that if there's too many of a particular species and they risk overusing their resources, then we implement policies, things like hunting, translocations, and some of those things to reduce the populations down. And if there's not enough of a population, we implement policies to help those species. So we do a lot of our own research. We do a lot of different management activities that you may or may not be familiar with. We are a government agency, but we are not your typical government agency in that we don't take state taxpayer dollars. So there's nothing from your income tax and nothing from your sales tax that comes to us. None of the general sales tax dollars come from us. We operate much more like a user pay model, like a business, and so it's the users of the resource that are paying for the resource. So that's where things like the hunting and fishing licenses come in. When you go and buy those, the money from that purchase is going directly to the management of those species. We do have a couple other funding sources. We won't get into a ton of that detail because that's not what you guys are here to listen to, but just wanted to highlight that a little bit. Again, my name is Eric Proctor. I'm the Wildlife Education Coordinator for the Arizona Game and Fish Department. In that role, I work kind of behind the scenes. So I work with you guys as educators. It's my job to help you bring local wildlife issues, local wildlife concepts into the classroom. We want to build a population that is aware and appreciative of the wildlife that's in Arizona so that they can make informed decisions, that they can participate ethically in outdoor recreation activities. That is our goal. And so we want to help you do that. So our focus obviously is going to be on Arizona species. I try to bring in some of the research we're doing, some of the cool stuff that we're doing to manage wildlife so that you can find interesting ways to bring those things into the classroom. Prior to this job, I was a middle school science teacher, so I taught 7th grade science in both the Littleton School District and the Kyrene School District here in Arizona. I've also got a lot of other what we call informal or non-formal science education experience. I've worked at the Phoenix Zoo. I've worked at the Arizona Sonoran Desert Museum. I've worked at the Challenger Space Center. I've done some curriculum development for a variety of science organizations. So there's that kind of experience that I bring to the table as well. But again, mostly I work with you guys. I do professional development opportunities like this, like these webinars. I do some in-person workshops that some of you have been to. I also do some curriculum development. So I will develop lessons and activities, not unlike the one that you're going to experience today. It hasn't been written up as a formal lesson plan, but it is an activity that I have brought into classrooms and I've introduced to teachers in a number of settings to bring into their classroom as well. So let's get to what we're here for. I'm going to set the scenario for you. The Arizona Department of Transportation wants to upgrade a portion of State Route 260 from 2 lanes to 4 lanes. I'm going to show you a map here in just a minute of what that looks like. Here is some context for that. This is a 17-mile stretch of highway just outside Payson. It is a heavily traveled high country escape by weekend vacationers. So this is people that are leaving the heat of Phoenix to go up into the high country to escape that heat. It also happens to have the highest elk vehicle collision, or what we will refer to throughout this program as EVC. You'll see that abbreviation in there. That's what it means, the elk vehicle collision. It's the highest rate in the state of Arizona, this particular 17-mile stretch. So this is where cars are hitting elk and other wildlife, but the focus of today is elk. And obviously that can be a significant issue. If you were to hit a 400, 500, 600-pound bull elk that's in full antlers when you're traveling at 75 miles an hour, that can cause not only some serious damage to your car, but it may actually kill the elk, and it may actually kill you or the passengers in your vehicle. In fact, the state has previously been found negligent in an elk vehicle collision lawsuit that cost the state millions of dollars. So that's setting the context of all of this stuff, of what the problem is that we're going to be understanding. So the big piece is we're going to be widening this road from 2 lanes to 4 lanes, so thus potentially putting more traffic on it, doubling or more the amount of traffic that this road can handle. So that's the context. So now let's look at the area that we're talking about here. So this is an idea on the left side of your screen. You can see what they want to do basically. Currently it's a 2-lane highway. They actually want to upgrade it to a 4-lane divided highway, so 2 lanes in each direction with a big median in the middle. You can see the map kind of puts it in perspective. The lower left-hand corner of the map shows the Phoenix area. Let me get my little pointer here to kind of show you here. So right over here, this is the Phoenix area in the lower left-hand corner, and obviously Flagstaff up on the north side of the map. We're talking about this little stretch of highway between these two yellow pins. This is about 17 miles. It's just after Star Valley. Right here in this corner is where Payson is located. This is Highway 87, and it splits off into 260. This is right before you start climbing the Mogollon Rim. Once you get up just past this area, you're going to be on top of the rim. That's where the lakes are that you sometimes might go visit. And then you would follow 260 further on to go to Heber and eventually to Show Low and Pine Top in that area. That's setting sort of the context of what we're talking about. But we're going to be spending our time in the 17-mile stretch of highway between these two pins. That's the focus of what we're going to be doing today. All right, so let's define the problem. What you're going to do here is I'm asking you a question based on the information I've just provided you. What problems do you anticipate, specifically to the elk situation, do you anticipate as this highway is expanded? As you come up with some ideas, go ahead and throw them into the chat box. So based on the information that ADOT wants to expand this highway, that it's already a high elk vehicle collision area, what do you anticipate are some of the problems that we might see as the road is widened? So go ahead and write some responses. And we're getting some good answers. I'm going to let a few more come in, and then I'll be kind of summarizing some of the responses that you guys are bringing up. All right. So some of the things that I'm seeing here is a wider highway means that drivers are actually going to drive faster, so we might see increased speeds. It's also going to result in what we would call habitat fragmentation. It's going to be harder for the elk that are moving through the area, whether they're migrating or not, which could increase the number of elk vehicle collisions that we already see in this area. It's also going to make it more difficult for the elk to cross the highway. Car speeds will increase. There might be less visibility for wildlife due to extra lanes. There are some good issues here. All sorts of good ideas. That's really the issue. And if you recall from the earlier context that I was setting, the state has already been held liable prior to this for being negligent in not appropriately managing our wildlife along highways, and we lost a lawsuit for millions of dollars because we weren't able to keep elk off the highway. So that is a significant problem to think about as we choose to widen this road. What are some solutions? Again, writing in the text box, what solutions can you think of to help Arizona reduce the number of elk vehicle collisions even as the highway gets widened and traffic volume increases? What are some things that we might be able to do? This is a brainstorming session, the same type of thing that you could do with your students. Again, this is modeling roughly what you could do in the classroom. I have changed a few things to make it a little easier to interact. A lot of this activity would be designed to be done individually and in small groups, so you would be moving your kids from thinking about this individually to small groups to whole class discussions. You might be doing some jigsawing and some stuff like that. I couldn't do that in this particular setting, so keep that in mind. I will ask a few more advanced questions of students than I will of you that I just don't have the capacity to do in this setting. But most of this you can do as is right from the start. So let's see people suggesting that we could reduce the speed limit. We could put fencing along the highway with escape ramps for elk. There's somebody who has some experience with this. Vegetated wildlife overpasses or underpasses at major crossing areas paired with fences to funnel the wildlife. Throughways under the highway, bridges for going over the highway, signage to watch for animals. So there's all these different types of ideas. And I will tell you that for the most part, a lot of these are being implemented. We're going to focus on one or two of these ideas specifically, but understanding that when we put these plans out there, we don't work on them in isolation. It's almost like a toolbox of solutions that we put out there in the attempt of making these highways safer. So good. You guys have basically nailed some of the big ones. The one we're going to be talking about today is an elk crossing structure. This is an example. It looks just like a bridge. I will tell you that the structure that you use in design is often species specific. We have to understand the biology of the animal in order to understand what's the best way to get them across the road. There are some animals that are perfectly fine with going under the road. They're not bothered by that. There are some animals that if you were to build an underpass that they go under the road, they won't use it because they prefer to be out in the open a little bit more and they want an overpass. There are some where you can build like a culvert or a little tunnel. There are some that need it to be more open. So it's very species specific. This is an example of something we might build for an elk. You can see it looks just like a traditional bridge. We're going to talk about the design of these in a little bit. But first, we're going to see if these even work at all. Are these worth the investment? So that's what we're going to be looking at, spending our time talking about elk crossing structures. So this is a detailed map. Again, you have access to this map that you'll be able to print out. I'm going to show you a slightly larger version a little bit, but I wanted to give you the overview section right now. So this is that stretch of highway that we're talking about. You can see off on the far left, you can see the town Payson kind of starts over there. It's at the junction of 87 and 260, just off your screen a little bit. And what we're talking about is this stretch of highway, roughly 17, 18-mile stretch of highway from mile marker 260. So here's the confusion. We're dealing with Highway 260, but the area that we're talking about also starts at mile marker 260. So that little green one just left of center, those signs are those mile marker signs. Those are the same ones if you're driving that you would see that tell you where you are along the highway. The round circle that says 260, that's from Google Earth telling me that this is Highway 260. Then there's a few numbered little dots that go from 1 through 17. Those are proposed underpass locations. After doing some research, we have decided that these are the places where we could potentially build an underpass. All right, so that's what those spots are. So that's the map to give you some context. Now let's go to the next question. I'm going to show the map down there in the beginning, but again, this is just to provide some context. You're going to see a larger map in just a minute. What we want to do is we want to know which of those 17 locations would be the best place to build a crossing structure. So again, this is where I'm asking for your input. So we're not asking you to identify the spot right now. All I want you to do is think about, from a scientist's perspective, you've been tasked with this project to figure out which of these 17 locations should we build an underpass at. What types of data would be useful to collect to help you answer that question? So write down some of your ideas. What types of data would help you determine where we should build the underpass? Getting some good ideas here. Again, I'm going to let you respond in a little bit. I'm going to let a few of these pop up, and then I'll start coming in with some of your answers. And of course, as we're doing this, you can think about all those types of things that the teacher in you is clicking off as far as what are your students doing, what, the critical thinking that just in this little bit, I haven't shown you any data, I haven't shown you anything, what types of critical thinking and problem solving skills your students are already trying to utilize. All right, so we've got lots of ideas. A lot of people are suggesting elk densities along the highway. Where are the larger populations? Where are they trying to cross? We could do that potentially with where are the current elk vehicle collisions, right? Because that might give us an indirect method of determining where they're trying to cross, is where they're actually being hit. Where are their food sources? Where would they be? Why would they be trying to cross? Identifying where those might be. We might use some data to identify migration routes or movement routes across the area. Breeding areas. Are there barriers to the elk? There might be areas in here where the elk just can't cross. Maybe there's a cliff face along the road, and it's just unrealistic for the elk to cross there, so we shouldn't even build an underpass there. The same could be said in general, just looking at the topography of the area, right? There might be areas where it's physically impossible or too expensive to build an underpass. It may be too much, so that might not be practical, because that's the other piece we have to keep in mind, is it's not just the wildlife side of this. There's a cost factor, a practical nature factor, all those types of things. So good, you guys are getting on a lot of the different things. For our purposes today, we're going to focus on tracking. There's a picture of an elk that happens to be a female elk. We put a telemetry collar on it. If you're not familiar, the collar, it's got a GPS on it, and it collects location data of where that elk is. In this case, we were taking location data about every 2 hours. We can modify that gap of how often we want to collect data depending on the type of research project. In this case, because we were monitoring them along the highway and we wanted to know where they were crossing, we wanted to narrow that gap down as much as possible. So we gave it a 2-hour gap. That gives us a better idea of where they're crossing. Because when you analyze the data, you're going to have a point here, you're going to have point A over here and point B over here, and the computer, when it analyzes the data, is just going to draw a straight line between those points. The animal might have had quite a circuitous route to get there, from point A to point B. We're going to draw it as a straight line. So if we want to know where they crossed, it's just going to draw it as a straight line, which is going to give us a rough approximation of where it crossed the highway. But if we made that gap too large, 6 hours, 12 hours, we wouldn't get an accurate representation, because it may be on the north side of the highway at one point, and then 12 hours is found on the south side of the highway, but that doesn't tell us really anywhere near where it may have crossed, because it might have moved quite a bit in that time frame. So we can collect that data, and then what does that data tell us? Here's an example of a map. Now, this map is not for the same area we're talking about. This happens to be for I-17, just south of Flagstaff, that little area right in the middle of all those yellow dots where you see all those black lines. That's the community of Munns Park, if you're familiar with the area at all. I like this map just to show the data, because I think it's really representative of what we can do with the data, and it tells a very telling story when you look at this map. So just to give you some context, this is like I said, this is the map of I-17 just south of Flagstaff. I-17 is that big black bold line that runs right through the middle of all those colors. Now those colors are individual elk. So the red represents one elk, the dark green represents another elk, the yellow represents another elk, and so on. Each of the colors represents one elk. Each dot represents a particular location for that elk at a certain time. The dots were collected then over the course of about a year. You can see down at the bottom it says elk locations along I-17 near Munns Park, March 27th, 06 to April 20th, 07. Okay. Just looking at this data though, knowing nothing else other than what I've just told you, what are some things that you notice about the map? Are there questions that pop out to you? Are there patterns that you see? Start jotting down some of those. Just some things that you notice as you're looking at this map. You kind of went, wow, I didn't even think about this. And again, while you're doing that, just to remind you, this is an example of what those collars can tell us. So we collect the data from those collars and we can map them onto maps, and this tells us some movement information about the elk. Okay. One of the biggest patterns that you guys seem to be pointing out is that elk don't seem to be crossing. There's maybe one that crossed. Some of you are pointing out that maybe the light green one crossed a little bit. There may have been one or two other ones that popped in there. The red one crossed a little bit, but for the most part, they're not crossing. They're going right up to the highway, so we can extrapolate that they were probably trying to cross, but they didn't. This is why I like this picture. For nothing else, if you're going to teach habitat fragmentation, you're going to talk about barriers to movement, barriers to migration, this map is an excellent visual representation of that. I-17 is clearly a barrier to elk movement in this area. They won't cross. Some do, but for the vast majority of them, they don't. So if you want to talk about habitat fragmentation, this map is a good visual to show how that can happen. Okay. That's why I like this one. It's one of the best ones that we have. We have lots of maps like this, but this to me is one of the best ones we have. Again, you'll have a copy of that map that you can get as a PDF. I believe the PDF that I have actually is an interactive one, so you can actually turn off the different layers, so you can turn off individual elk if you just want to look at certain ones, and so on. So that's going to access. Now let's go back to actually looking at the data for the area that we're in question, outside Payson here. So in addition to making those maps, the one thing we can do is we can turn those maps into actually usable data. So that's what this chart on the right-hand side of your screen shows, and I'm going to explain it to you. Again, if I was presenting this in a classroom, I would probably be having my students look. I wouldn't. What I like to do is give them a graph and not tell them anything about it. Give them about 5 or 10 minutes in small groups, or individually or in small groups, to kind of look at the data and tell me what's going on with it. We don't have time for that today, so I'm going to interpret a lot of these graphs for you. I'm going to kind of tell you, okay, this is what the graph is showing. Understand that in the classroom, you might be presenting it a slightly different way. So the graph, the x-axis there has been converted to show the mile markers. So where it starts at 260 and goes to 276, that closely lines up again if you look at the map that's in the lower left-hand corner. And again, you're going to get a bigger version of this in just a minute. I just put it there to provide some context. That green mile marker that's on your map, that's sort of left of center, that's 260, so that's the start of our mapping area. And then the final green marker is 278. So you can see that roughly that number 17 that you see there on the map coincides probably somewhat close, maybe a little bit past where the graph shows at 276. So this 260 to 276 is showing you mile markers along the highway. So that's what the x-axis is showing us. The y-axis is showing us number of elk crossings. So the higher the bar, the more elk crossings there were in that particular segment of the highway. Each red bar is representative of 1/10 of a mile of a freeway section. So that's what each red bar is. We've divided the highway into 1/10 of a mile segments. And we've been able to document the number of crossings that occurred in each 1/10 of a mile segment along this highway. So with that understanding in mind, here's the question I have for you. There are 17 potential crossing structure locations. However, we can only build at 3 of them. Your job is to figure out where would be the 3 that we would build. Based on the information that I've given you, you use the map and you use the graph to determine where you think the 3 best locations for crossing structures would be. Once you've done that and you have your idea, and I'm going to show the map and the graph in just a minute. Once you've done that, if you'll jot down your answers in the text box, just tell me the number of the crossing structure location. So for example, I'm going to bring up, so here's the map. I've zoomed in on the map just for that section, and I've given you a slightly larger version of the graph. All you need to do in the box is tell me which numbered area you would build the crossing structure of those 17. So maybe you decide, I would build them at 11, 12, and 13. Put that in there. If you want to provide a brief explanation for why you chose that, that would be great as well, but I'm not necessarily going to require that. So if you'll spend a moment looking at the data and looking at the map and finding your 3 locations, where would you build crossing structures? All right, so some of you are putting in mile markers, and that's great. What I want you to do is try to translate those mile markers, though, into those numbered white circles as best you can. So the numbered white circles are the actual physical locations. They may or may not coincide directly with a mile marker, but get them as close as you can. So if you put in there 265, for example, where do you think 265, which of those would best represent 265? Sorry for the confusion on that. But I actually added that as sort of another level of analysis that your students are doing. They have to take data in one form and interpret it and put it into another form. So they're reading it as mile markers, and now they have to read the map to figure out where those mile markers are and identify. So it's just another level of analysis that I wanted the students to be doing. So we have some responses coming in already. Remember, you guys have 3 potential options of where you can put them. And if you're done and we're waiting for a couple more people and you want to briefly explain why you chose what you did, I don't need a huge explanation, but if you want to try to explain why you picked those locations, that would be great. So what I'm seeing in responses is I'm going to mark a few of these here. I'm not going to mark every one that got picked, but you should see a little red X that appears. I've seen a couple 1s, I've seen a couple 2s. I think I saw 4s. I saw some 6s. You should see some red marks coming in. Let me see where else you guys picked for some spots here. It looks like you picked 13, 14, 15, maybe 16 got popped up here a little bit. So I'm not going to mark every single one. What I do with students on this one is I have a big printed version of this map on the wall. And then I give them little stickers, little red stickers or colored little dots. And then as a group, they discuss them. And then they go and they put their dots underneath the numbers, kind of like I did with those X's. And then what you can do now is you can start seeing which ones are getting picked the most by groups of students. You can even create a bar graph if you wanted to from that. I'm just putting some general ones that got picked from you guys. So read some of the explanations that you guys provided. You guys have indicated that 1 or 2 seems to be right around where that initial peak is if you're looking at the graph. You have a big cluster of crossings that are occurring in that area between 260 and 264. Particularly towards the beginning of that. So a lot of you have said, okay, 1 or 2 seems to be hitting that the most. 15 or 16 seems to be hitting maybe the other peak that is over there on the right-hand side of that graph. So 15 and 16 seems to be hitting the other kind of peak. And then some other people said, well, 6, 4, that area might be hitting sort of a midpoint, that we don't want to exclude those, even though there aren't as many crossings in the middle section. Some of you are saying that it might be too far for them. If they're trying to cross in the middle, it might be too far to expect that they can get to one of the ones on the end. Okay? I will tell you that when we do this with kids, we get almost exactly those same answers. And it makes sense, right? The reasons you gave are exactly right. What you're trying to get the kids to think about is they want to intercept where the most crossings are. There's no right or wrong answer for this. But as long as they can justify that, well, yeah, there are these two big peaks on the west side and the east side, and then the middle one is always the one that gets up in the air. Some groups choose to build another one in one of the peaks, so they might build two near the left-hand side and then one on the right-hand side, or vice versa, and ignore the middle, which is fine. Again, as long as they can justify why they chose to do it, they could be saying there's far more crossings there, so we need to intercept those. Most other people say, yes, we want to get something in the middle, so right around that 268 time frame, that area. So maybe number 5, maybe number 6, somewhere in there is going to hit us the best. So you guys have nailed more or less what we see with the student responses. So that's talking about crossing structures. In just a little bit, I'm going to show you whether or not they work, but what I wanted to talk about now and get your feedback, and some of you have already provided some of this feedback, is what else could you do? So we're going to build an underpass. We're going to build 3 of them, right? What else could you do in conjunction with the crossing structures to try to get more elk to use them? If you have some thoughts, go ahead and write them down. Some of you have already mentioned some of these, so it's just getting those thoughts there. What I really like about this activity, again, as you guys are writing that down, is I'm a big proponent. I think that it's empowering if students can analyze the same data that scientists have, and they can come up with the same solutions that scientists are coming up with. I think that's very empowering because it tells a student that science isn't this far-off thing that they don't have access to. To become a scientist, to do real, legitimate science, isn't that far off. We can do it in our classroom. We have the skill set. We have everything we need. It's just a matter of using our brain in the right way. That's what I like about this activity. They're going to come up with a lot of the same ideas that you guys have come up with. I've done this for a number of groups, and I've never had somebody not get the answers I'm looking for. Okay. And for the most part, you guys are nailing the response. Put in some fencing. Put fencing along the road that's going to funnel them to the crossing structures. Now, there are challenges with putting fencing. We can't put fencing along the whole road, largely because, 1, it looks kind of ugly and we don't always just want to have fencing there. But 2, there are smaller roads that intersect with this highway along the way, and when you have an intersection, you can't put a fence across that intersection. It doesn't work. And so there are going to be gaps in the fencing. But if we can strategically place fencing, then we can hopefully direct them. If they're not going to cross where the crossing structure is, hopefully they'll hit the fence and we can direct them to the crossing structure. We also got some other ideas, is luring them, maybe almost training them to use the crossing structure. So putting food or something else to lure them over so they train them to use the crossing structures, and now it just becomes habitual. Hopefully over time you don't have to use those. Masking the underpasses so that they seem more appealing, making them what we might call wildlife friendly. We're going to discuss that concept in just a minute here. Water sources, those types of things are all good ideas. What we're going to be talking about for the purposes of this activity is the fencing. So we're going to assume now that we're putting fencing in to help direct them. I'm not going to go through a whole activity to determine where they need to go. That's a whole other piece that we just don't have time for. But what we're going to do now is we're going to assume that we've done this, because we have. What I will tell you, and this is the caveat that I'll give you, I actually made this more challenging for you than than the scientists had. We actually built crossing structures at all 17 of those locations. Okay, if you were to drive that highway now, those crossing structures are there. They are bridges, they are underpasses, things like that, and they exist on that highway, that stretch of highway. You just drive over them and you don't really notice everything that's going on there. They just look like a regular bridge that you're driving over. A lot of them have been designed specifically for elk. I limited it to make the challenge a little bit more for you, to make it 3. So that difference is there. Now, because this has been going on and we've had these in place, we can now determine whether or not they've been successful. They cost money. They're actually a little bit more expensive to build an elk underpass than we would if we were just going to build a traditional bridge. A little less convenient. And so we have to be able to show that they're successful. Otherwise, why are we doing it? So that's what you're going to do here in a minute. I'm going to show you a series of graphs, some different data that we've collected along the area, showing before and after the underpass and fencing. And then you can tell me at the end of all these graphs whether or not you think it's successful. It should seem pretty obvious. Again, This is an example. When I show these graphs, I would first ask the students to interpret them. I'm going to do that part for you, at least show you what the graph is showing, just to make sure we're all on the same page, because I don't have the capacity right now to open up your mic and have you explain to me. So this is the first graph I'm going to show you. And just for context, in case graphing is not your strong suit, the x-axis, the lower axis there, is showing traffic volume. So as you go further along the x-axis, further to the right, the traffic volume, the number of vehicles per hour on this stretch of highway is increasing. The left axis, the y-axis, as you go up, is the passage rate of elk on the highway. Now, we are defining passage rate as the number of crosses, the number of times they cross, divided by the number of times they approach the highway. Because not every time they approach the highway, they're going to cross. So the passage rate is how many times do they cross in relation to the number of times they approach the highway. For example, they might approach the highway 10 times over this period of time. They might approach the highway 10 times, but only cross 5 of those times, in which case it's a 50% passage rate. That's what this is looking at, is it's comparing the passage rate of elk along the highway as traffic volume increases. And what you see under these two graphs, and I'll actually point this out here, is that the crossing rate at the underpasses is not affected by volume. So as the traffic volume increases, the passage rate does not seem to be impacted. Compare that now to at highway. So where the lower graph, the graph that's going down, that's them just trying to cross at the highway, not at a crossing structure. Okay, the top graph is at a crossing structure. The bottom graph is just at a highway where we didn't put a bridge in place. And you can see that at the highway, the passage rate, the successful passage rate, goes down significantly as the traffic volume increases. So that's one graph that we'll be looking at. Again, keeping that in mind, at the end, I'll have you tell me whether or not you think this was worth it, the investment of building these crossing structures. So here's another graph. So this is looking at years. And this is now looking at the number of elk vehicle collisions that occurred in this stretch of highway each year. And that dashed line is when this project was completed. When the crosswalk and the fencing, the crossing structures, or there's another thing in there, a crosswalk that we're not going to talk about, but the fencing, all of the stuff was completed between 2006 and 2007. You can look at the data. Okay? Again, I would be having students tell me a little bit about this. I just want you to internalize all this data I'm showing you and tell me at the end whether you think this is successful. It's been a 97% reduction in elk vehicle collisions as a result of this. Here's another one. Now this is incorporating elk and deer, so it's a similar data to the one you saw, but now it's looking at just over the course of a year roughly. That black line in the middle of the graph is when the fencing was completed. So we had crossing structures in place, but then we built the fencing along the highway, and that indicates when both of those were done. The fencing and the crossing structures were done right in the December time frame of 2004. And you can see the total number of deer and elk crossings is the red line. And what happens after the fencing is completed. Okay, again, our goal is to continue to allow elk to cross the highway and lower the number of elk vehicle collisions. That's why we're doing all of this. We want to increase the porosity of the road so that elk can move through and within and around the road, but not be hit by cars. All right, now this graph is a little bit, these are two separate graphs that represent two pieces of time. One, and this is just a specific section of this highway. We have this graph for all of them, but I'm just showing you a specific section. The one on the left is 2004. The one on the right is 2005. So what does that mean? If you look at the tan line, that's Highway 260, the highway we've been talking about, and you can see it's segmented. It's broken into segments. That's that same tenth of a mile segments we were dealing with on the original graph that I showed you. The colors, the green, yellow, orange, and red, represent in that tenth of a mile section how many collisions were there in 2004 or 2005, depending on which graph you're looking at. The black outlines, that represents where there's a crossing structure. Okay, so you can see on this single image, you can see the highway, you can see where the crossing structures are, and you can see where the collisions are occurring in 2004. The 2005 one has one more piece added to the image, and that's the fencing. And you can see that sort of shaded area. You can see it doesn't stretch the whole highway. We couldn't put it along the whole highway, so we strategically placed it in certain areas. Now, looking at that, again, you can start drawing your conclusions about whether or not you think the crossing structures in conjunction with the fencing were successful or not. This is looking at collisions in this particular stretch of highway. Well, you can see here, pre-fencing, there were 51 collisions, and then post-fencing, there were 8 collisions. 84% reduction in collisions. So now, before I move on, I guess I'll throw it out to you guys. Based on what you've seen, are these types of structures worth it? Simple yes or no. Don't need a full-on explanation. Are they worth it? Are they worth it to build these, invest the money in these, invest the time to research them? Do they successfully increase elk or wildlife mobility in the area while also reducing the elk-vehicle collision rate? Looks like most of you are saying yes. Not surprising. The data was kind of showing that. Again, you'll have access to all these graphs. You can have your students be doing the exact same thing. Again, I like to have them try to figure out what the graphs are saying first before I tell them. I told you that in this case, and I would have them going through and analyzing in that way. I just wanted to make sure we were all on the same page with you. Good. Most of you are saying it was successful, saying we might not collect all the data. There might be collisions that aren't reported. That is very true. Oftentimes people report the roadkill on the road, so that gives us a rough idea. It's also hard to not report a collision with elk sometimes because it's going to cause some significant damage. What this isn't pointing out, which you can kind of see, particularly if you look at this one graph that we're looking at, the one on the right that has the fencing, what you'll notice in a couple areas is that the number of collisions has significantly reduced. However, at the end of the fence, there seem to be collisions. So right in the middle, where you see that green number 1 and yellow number 2, that's right between two fencing, where there's two fences. And also on the right-hand side, you can see a crossing structure and a fence, and then there's collisions right at the end of that fence. This is a problem that we have noticed. It's called the end of fence effect, right? So over the course of the whole stretch, we reduce the elk vehicle collisions, but we may see a small uptick in collisions in the area where the fence ends, and that could be ending because there's a road coming in. It could be the end of the project, and we have a whole nother solution for dealing with that. I just don't have time to talk about that. We've actually constructed an elk crosswalk that can determine at the end of a fence. It can identify an elk, and then it sends a warning to drivers on the road that there's an elk in the area, and that's been pretty successful as well. And if you've driven that area, you've actually probably have seen that warning system that's put in place over there. But that is a factor that's occurred, is what we call the end of fence effect. But overall, it has been successful. We have reduced the number of elk vehicle collisions. I want to touch on one final piece here. This gets into some of the engineering and design aspects, and you could take this as far as you want with students. You could actually have them constructing some underpasses and thinking about that. We're not going to get quite that far. We're just going to look at the data really quickly. I pose the question here, are some crossing structure designs more wildlife friendly than others? You guys have already proposed that idea, is making them more wildlife friendly, putting vegetation on them, making them more appealing. So I'm going to throw it back to you now. What features would you put on a wildlife friendly crossing structure? What would you do to a crossing structure to make it more appealing for elk to cross? Go ahead and put a few responses in there. What would make elk want to cross at the location you want them to cross at? What could you do to the crossing structure? It might be things you do to add to it. It might be the way that the physical structure is designed. We have some good responses coming. Some people are saying make it look less man-made, make it look more natural. Putting in a noise buffer so that when cars are going over the bridge, it doesn't echo as much when you're under the bridge. We're hearing vegetation, pheromones, food, drawing people into it. Of course, the challenge you have when you're trying to draw some animals in is you may be drawing other animals in. So is it going to become an area where predators hang out now, especially if you're talking about food or water? Plant shrubs, grasses to increase the natural feel, potentially shield the view so that the elk don't see that it's a highway. These are all really, really good. Now, this project just so happened to have another feature to it that was coincidental. This wasn't planned. Down on the bottom picture there, you're going to see a Google Earth view of a very small section of this highway. down in that big green valley you see, that's actually called Little Green Valley. If you've driven this road, you've undoubtedly driven by this. So Payson and Star Valley are just off to the left of this map. Okay, so this is right at the beginning of our project, right around that 260 mile, a little bit after that 260 mile marker. But there just so happened to be two bridges that were needed in the same area. As it turns out, ADOT built these bridges, and they built them very different from each other. You can see the images on the top, the left and the right. They look very different from each other. So this allowed us an opportunity to see, okay, are there features about these underpasses that may be more appealing to elk than others? Because here's the deal. The north side of both of these, you can see in the overview map and you can see through, is pretty heavily dense forest. On the south side, it feeds into this valley, this green valley that elk are commonly seen in, grazing, and the underpasses happen to be really close on the highway. So if all things were being equal, if the design of the underpass didn't matter, because of all the other features, we would expect that the passage rate of these two underpasses would be basically the same. Okay, that there wouldn't be a difference in them if the design of the underpass didn't matter. That elk were just using it to get across, and it didn't matter what it looked like or sounded like. So that's the overview. Now I'm going to give you some data on these two crossing structures. So here's the information. You can see the specifications for them. Some of these require a little bit of an explanation. The distance the cars travel on the bridge, so that's basically how long are the cars on the bridge. The height, you can see there, the one on the left is 22 feet, the one on the right is 38 feet. The opening between the east and westbound lanes, so this is the gap between the two lanes, the opening in the middle of the highway, and how big that is. The width is basically how far at the base that it is. So on the ground, how wide is the underpass? And then the distance that the animals have to cross to get all the way from one side of the crossing structure to the other. You can see the one on the left, it's 173 feet to get from the side we're standing on to get to the forest. And on the other one, it's 360 feet before they get to the end of what we would call the crossing structure. So that's the data. Now, based off of this information, which one, number one or number two, as they're labeled on the top, would you think is more wildlife friendly? Or is it not going to matter? Okay, that could be your solution too. Is underpass 1, are we going to see it be more successful in elk crossing? Is underpass 2 going to be more successful with crossing elk? Or is it not going to matter? You'll just go ahead and put your responses in there. Looks like most people are saying number 1. So let's take a look at the data. The top part tells us that that's the number of elk that approached the underpass. Now this number is not as important. We don't use this one to compare as much. Just because there were 1,800 elk that crossed number 1 and only 750 that crossed number 2 doesn't mean that one was better than the other. What we need to look at is how many passed in relation to that number. Okay, and that's where the number of elk that crossed the underpass, which we then use to determine our passage rate, which we defined earlier as the crossings divided by the approaches. You can see that underpass 1 had a 75% passage rate, while underpass 2 basically had a 50% passage rate. So half the elk on number 2 that approached it did not cross through. However, 3/4 of the elk on number 1 that approached it ended up crossing. Now, what was cool about this is not only did we have GPS data triggered on here, but we also, because these bridges were so close, we actually needed more information. So we put cameras on these underpasses and on the road, and we could monitor elk behavior. So we could watch what elk did when they approached the road. We also had cameras under the underpasses, so we could see, like, when a car went over, did that change? And they were under the underpass when the car was going over, or when a truck was going over, did it change their behavior? So we started to monitor elk behavior, and that's where the data at the bottom comes in. You can see that how quickly they crossed really didn't change. 55, 57% between the two crossed within 10 seconds, so they quickly went across the underpass. The second number isn't much different. It's basically the flip of the passage rate that you have. What I think is most interesting is the fled quickly from the underpass. So this means they tried to cross, were in the underpass, and something happened, and they left. They ran out as quickly as they can. They didn't cross. They turned around and booked it the other direction. And you can see that 1/4 of those that approached and tried to cross actually did not cross on the underpass number 2. We're only about 10 or 13% of the first one fled quickly from the underpass. Based on this information, it would tell me that most of you, the ones that said number 1, were correct. We could determine that, yes, the design of the crossing structure matters. Again, if I was doing this with students, I would actually have them designing it. I've done this in 2 different ways. One, where you give them some materials and they have to build a crossing structure. The other, I've given them a picture of Underpass 2, and I've actually had them redraw it, like make changes on the picture of what they would change to make it more wildlife friendly. You can incorporate some of that engineering piece into this lesson as well. That, for the most part, is the activity you know, there are some extensions you can do. You know, a lot of the stuff will be included in the resources that are going to be provided. Thank you all for attending. I hope that was worthwhile and that you got something out of it. So thank you, guys.